So I mentioned the fact that in the host portion of the address, we're going to throw away a couple addresses here. We're going to throw away the all zeros in the host bit, and we're going to throw away the all ones. Well, not only throw away, but we're going to reserve them for specific uses. In particular, all zeros in the host portion, in this case I'm showing a Class C network address, 192.168.1 was the network portion. So the first 3 octets are network, it's Class C, and then the last octet are the host bits. So in this particular case, we've set all the host bits to 0. Now that has special meaning. That's actually used by our routers to determine the hierarchy of the network. Now the router's job is to determine the best path through the network, and they're not routing based on the host bits, they're routing based on the network bits. So trying to find a network in a multitude of networks through the internet, we're routing based on the destination network bits. We don't necessarily care about the host. So when we set all the host bits to 0, that's the actual address of the wire. That's the address of the network itself, not any corresponding host, but the address of the network. And the routers are going to use this address and find the best path to that network to make sure we have an optimal connection to the network in question. Now, if all the host bits are set to 1, in this case 192.168.1.255, that address is set aside specifically so we can send a message to all the hosts on that network. Now, there's some caveats there, which again we'll go into that later. But this message, if we send it out, it should send a message out to all the devices that are on that particular network, not just a message to one specific device like a unicast, but a message out to all the devices on that network. Now you'll see throughout this course that we're using specific IP addresses in our examples. Now these IP address ranges have special meaning because they're considered private address space. They're specifically set aside by the IETF, that's the Internet Engineering Task Force. Those are the guys that create the standards that create the Internet. That's one of the advantages of the Internet itself. Like IPX that protocol was sort of owned by Novell, and AppleTalk owned by Apple. In the case of the Internet space, or IP, it's owned by, well, really all of us. Any of us can go join the IETF and show up at the meetings and suggest our options to be added into the Internet protocol, if you will. Those working groups that work on different parts and pieces that make up the overall IP protocol work on particular projects. Those become drafts and eventually become standards. Now, a standard in IP is referred to as an RFC, or a request for comments. Now, the request for comments documents are all numbered, and some of them obsolete other ones, but there's a specific one that's important to us in this case, and it's RFC 1918. Now, RFC 1918 identifies the private address space ranges that we're supposed to use inside of our company, but isn't routable out on the internet as a whole. Perfectly routable inside of your enterprise, but not something we're going to actually send out to the internet. So if we get out to the internet, we use a technique like network address translation or something else to send these addresses out to the rest of the world, or simply not communicate with them. So there's a Class A, a Class B, and Class C range for private address space. So the 10 networks specifically been set aside in the Class A space. From 172.16 through 172.31 has been set aside for Class B, and the whole block of 255 or 256 Class C addresses of 192.168.0 through 192.168.255 have been set aside for the Class C space as well. There's some other stuff that's been set aside as well, on top of that, and we'll talk about multicast addresses. There's some multicast private address space there as well, and some other stuff. You start getting into higher-end routing protocols like the Border Gateway Protocol. There's some set-aside numbers there for that are private. So there's a bunch of things in that standard that you could go and pick up and read. And if you really want to learn how this stuff gets put together, pick up a couple of the well-used RFCs like RFC 1918 or a few of the other ones to kind of get an idea of how these standards actually work and how the standards bodies work to design these particular protocols. Also, if you've got insomnia, this is great reading. You print out an RFC, take it to bed, start reading it, guarantee your insomnia is gone because it'll put you right to sleep. It's about the most boring, dry reading you'll ever get your hands on, but that's how the standard works. And the nice thing about these standards is if the particular vendor implements, some, standard like OSPF or, some standard you pick on, and, you see that the vendor isn't doing something right, you go back to the standard and go, hey, it's supposed to be done like this, and you're not doing it like this. You can take it to the vendor and say, you're not being compliant with the particular standard, and they've got a bring it up to speed and make sure it's working the way that the standards body says it's supposed to work.